Hello there. In this video, we're going to go through another aspect of the QPython package. So today we're going to go through routing objects. In a previous video, we covered the idea of transition matrices, but there are some newer classes in some of the recent versions of Q that have come out. And so we're going to start exploring that. There's roughly speaking two types of network routing objects. There are node routing objects that determine the routing at a particular node, and then there are network level routing objects that do some more orchestration at the level of, well, your queuing network. Okay, so let's jump into just take a look at some examples. First of all, I have to import Q, of course. And next, let's create our usual network object. Let's call it network and go Q dot create network. And I just realized I could really do with turning on what did I call this thing? Use routing objects. There we go. There we go. So now we get a whole deluge of stuff. Actually, before we finish defining the network, let's actually skip that for now. Let's go into routing, defining a routing object for the entire network. So we'll go Q routing and then network routing. And in this, we can pass in different routers for different parts of our network. And this gets passed in, it'll get passed into something else later as a list, but okay, let's start with our first node. And we're going to suppose that this network has 4 nodes, so we need to provide 4 network objects. First one we'll talk about is direct, and we might say 2 is equal to 2, maybe. Well, what does this mean? It means that, assuming that this node is our first node in the network, it means always send, we'll call them customers for now, to node 2 from 1. If you're starting at node 1, always send to node 2. That's what the direct does. Just sends them directly there. So another one that might be worth looking at here is probabilistic. And really what that means is creating a stochastic matrix. So we have a destinations argument parameter here. And what we pass into that is a list of integers representing the possible places you might go. So just to follow the documentation here, maybe we say 1, 3, and 4. And then also similarly, we need a probability distribution for the probabilities of going to each of these different nodes. So maybe we've got 0.1, 0.5, and 0.4, just for the sake of example. So this one, unlike the first one, it's not guaranteed where the customer ends up going. They go to one of a variety of different destinations with some probability. Okay, then let's, okay, the documentation is showing an example, which I don't think is adding much that's new, but let's throw it in anyway, which is to say, what if there was only one destination, but with like probability of, let's say, 2.5? What does this mean? Well, you're at the third node, and you're at the third node already in this list, right? So if the destination is also 3, it means the probability of sending a customer to itself, and that happens with a probability of 0.25. Now, in this example earlier, 0.1 plus 0.5 plus 0.4 adds up to 1. This clearly doesn't add up to 1. So one of the implicit rules here is that if the probabilities don't add up to 1, the complement, the extra probability that isn't specified, means the probability of leaving the system altogether. Now, you might actually want to have a routing type that says leave the network no matter what. And that's what this leave does. A router that sends the individual directly to the exit node. I should probably read these documentations for you, or at least show them to you. So the probabilistic one says initialize the routing object. It takes destinations, a list of node indices, and the probabilities, a list of probabilities associated with each destination. Be careful. You may have noticed this in previous videos, and maybe even noticed it in this one, that when it says a list of node indices, it is assuming that the 0th node is the arrival node is an arrival node that models all the arrivals in the system. So generally speaking, don't specify that one. And then direct initializes the routing object, and it is the node index that will always send the customer to. It is the node that the customer will always be sent to. So that's where the network objects are defined in a pinch. But I'm just going to scroll down in the documentation here. Great. So you might be then wondering, okay, well, we've defined this routing object, this network routing class, sets up the router objects for each node. That's fine. But where do we supply this in when we're defining our model or simulation? Do we pass this into network? Do we pass it into the simulation class? Where do we pass this? In Q, you pass this into the network class. So we could go network, and that's equal to or bound to the value of whatever create network is. And just we'll throw in a pretty simple example here. Let's just say dists exponential rate of 1. And we're not going to focus too much on making this interesting or realistic in any way, but we'll say service distributions. We'll set those to rate is bound to the value of 2. And so to get to the part where we put in the routing is actually pretty straightforward. We just need to put in that there's a routing argument, and we pass in routing. And the other thing I'm missing here is putting in the number of servers. So we might say 1, 2, 3, 1 or something like that. Oops, I'm not used to this keyboard. All right. Okay, so routing goes into the network, and network goes into the simulation object. So the simulation part is just as we've seen it in previous videos. You pass in that your network is equal to the network, and then you might go, simulation, simulate until max time, maybe 200 or whatever. Okay, so that's the gist of it, really. There are other kinds of routing objects, and you can also define custom routing objects, which we might get to in another video. But one of the things to note is that it is for this keyword of routing inside of create network, or this parameter called routing, you need to pass in a network routing object, not a node routing object. So hopefully that's useful for getting you started. I think that this is already a pretty good start, but there's other things we can look at that I think we will look at in future videos. So with that, I will catch you in the next video. Have a great day.